Good morning and welcome to Race Industry Now, the weekly webinar series from ePowerTrade, presented to you by ARP, Performance Plus Global Logistics, Peak, Ferrea Racing Components, and Fifth Third Bank Motorsports. I am Francisque Savignan, the founder and CEO of ePowerTrade, the global platform for the performance and racing industry. Otherwise, the racing industry every minute, every day. This is episode 444. We're going to be hosting line-to-line coatings for part 2. We had them on about 2 weeks ago, and we barely covered half of what they had planned to talk about. So we're inviting them for part 2 today. With me this morning are Judy Keane, the co-founder of ePowerTrade, and our superstar and wonderful host, Mr. Jeff Hammond. Judy?
Thank you, Francisque, and thank you everyone for joining today. I wanted to take a second and remind people that on this platform, we have a section for buyers to post needs. It's an RFP page. So if you're a buyer out there, a racetrack, an engine builder, and have a need for a product or a service, find it, post your need, and suppliers will reach out to you. So it's a really important section on this platform. So I just want to remind people. Jeff?
Well, the thing is, Judy, I mean, you guys have made it so simple, and you keep trying to make it even more simpler. So I always like that, and I'm glad you're reminding all those out there that are listening this morning. And yes, I'm really jacked up about the fact we get a chance to do a follow-up with these guys from line to line, because again, they had so much stuff and so many different people asking questions. I think that we got a little bit overwhelmed, but today, we're going to basically let Andy and Mark and Woody take the ball and run with it early on. And hopefully we'll get through all the slideshows, and we're going to have time for answering questions at the end, and we'll take care of it. And I guess we're just about ready to rock and roll.
Good morning, Andy. I see Andy. We see Mark should be on, as well as Woody. And Jeff, we'll let you take over.
All righty. Let me see. Yeah, we're all here, and you guys look real familiar. Like 2 weeks ago, I think we were doing something and talking about all your great coatings and stuff that you guys can do. And we got a little overwhelmed with a lot of questions, and we didn't get a chance to get through all the graphs and all the information that you had to share. So today, I'm going to do something. I'm going to get me a cup of coffee. I'm going to kick back here with my feet up. I'm going to let you guys take the ball and run with it, and then we'll answer all the questions that come out of this thing, because I think we got a lot of interest. I think that's the good part about it. We got a lot of interest, guys.
Sounds good.
Well, thank you, Jeff. And yeah, because of all the great questions that people were submitting, and that material that we were able to cover at that time, there was quite a bit that we weren't able to get to. So thanks for inviting us back. And at this point, I think we'd like to jump back into the presentation, maybe do a brief recap as we hit those particular slides, but get into some new material and take more questions.
Well, like I say, I'm really looking forward to it, because again, we hit some good nerves, I think, the last time, and I'm glad we're able to come back so quickly and give everybody who had their appetite whetted, you might say, to a certain degree, that we'll be able to, get that information out there to them. So like I said, Andy, you guys, y'all take the ball and run with it here, because we want to make sure we get through here today correctly.
Great. Thanks a lot, Jeff. Just got to start my screen share here, and then okay. So yeah. Appreciate you guys having us back so quick. Yeah, we have a lot of material. Last time I was kind of on the rev limiter the whole time. I'm going to try and back off. We're going to zip through a lot of slides. We'll slow down a little on the ones we didn't cover. And Mark and Woody are going to jump in quite a bit more this time with their experience. So here we go. And these slides, they'll be available on line-to-linecoatings.com. So there's a lot of detail in some of them, and you might want to check them out. So these are just some of the components where we really started off: superchargers, turbos, pistons. This was a quick slide, a 2D showing roughness of our coatings. That's important to the way they fit themselves to the adjacent parts. And they plateau all these peaks off to meet the surface of your mating part. Here's a couple 150x microscope shots with a lot of verbiage you can review later, but basically it's rough and fuzzy and then you put it together, run it, you get all these nice plateaus, oil wedges and nooks and crannies for material to hide if something gets in between or more wear occurs. Woody wanted to say a little something. This one's got a ton of info on it, and let Woody
Yeah, I think if you click back to that previous slide for just a second, Andy, one of the real key elements to understand about this coating and why it works, what makes it work, is the fact that we hold oil. You retain oil in these little pockets. And, you know, that's basically in effect going to, in the case of a piston skirt, you know, you have a volumetric capacity of oil in that crosshatch in the bore. Now you have an equivalent or near equivalent in the skirt contact patch area. You retain oil in that. This is where the real meat and potatoes of this coating, you know, comes into play. So go ahead and go to the next slide. If you look at this, we talked about the Strybeck-Hutchins fitting curve in kind of more of a shirt sleeve English discussion. If you look into the green box and you're a piston skirt, that's where you want to operate down there on that curve. As you get over to the left there, you start to get into that boundary layer area. Things can start to go south in a hurry. That's where piston scuff is going to occur. And some people have called me and asked about, well, I'm using much better oil today than we were in years past. And that's true. You know, there's been a lot of development, especially at the molecular level in oils. And the guys we've talked to, like, you know, Lake Speed have conditioned us to all understand that. That doesn't mean you still don't need to operate in this high dynamic region. You know, once you get into that near contact area, you know, things go away for you in a heck of a hurry. So that's basically where we want to operate. We want to keep that piston skirt into that hydrodynamic lubrication range. Go ahead and go to that. Yeah, there we go.
Yeah, this is the key slide here. You know, on the left, you see that red spot that's carrying most of the load. That's a typical gauge point on a piston. And what we're able to do with the coating when it fits itself to the bore is we safely make a bigger footprint, and we transfer the load that's on that red spot on the left to a larger area. So you don't have a peak load oil point where your oil's trying to get pushed out of there. The oil wants to stay because it doesn't see the sharp pressure gradient when you have a proud gauge point. So I've got a couple of parts here that were in the same engine, and you know, you can see this one was carrying load in a couple of places, and yeah, these were in the same engine. And the black one with our coating, the whole skirt's engaged, and therefore you don't see any distress spot. So with the nooks and crannies Woody mentioned and the larger footprint and uniform oil film pressure, that's really what makes this stuff so awesome on pistons in terms of friction and wear. And then we also talked about the integrated skirt clearance. You know, that's all the other areas that would have a thick oil film. That's all the space that your piston can rattle around in. And if your piston's rattling around, your rings are trying to stay sealed to the bore and to the piston. It's pretty hard if it's rattling around. So settling that piston down a bit can make a huge difference.
We got a couple slides coming up a little later that do a good job of illustrating what that integrated skirt clearance means.
So this is Mark, you want to take this one, or I don't want to keep talking?
Well, you are the guy who knows what the coating's all about. What this illustrates, this was an engine builder who was having a scuffing issue in his Outlaw 358 sprint car engines. In fact, he made the comment to us that he used to lay awake every night thinking about tomorrow's race and whether he was going to encounter that situation again. Came to us for coating, and his scuffing problem went away. And I think on this slide you can see where it's illustrated that the highly loaded area would be where the scuffing would normally occur, but because the coating is spreading the loading across a greater area, it's able to eliminate that situation. It's holding more oil in, it's stabilizing the piston, and essentially cleared up his problem.
So to beat a dead horse, there's another piston. You can see the whole skirt's engaged.
Now, this is just an example of the fact that we are on all different types of pistons and pumps too, in engines and pumps. We've got 2-stroke, 4-stroke diesel. We've been in refrigerant compressors, air compressors, any area where you have a piston moving air or power, we can help seal things up and make them work more efficiently.
So this was kind of the start of line to line. We got into automotive, high volume automotive superchargers, and there was a need there for a low cost way to create higher precision devices. And in that case, it's probably on 8 to 10 million cars on the road these days around the world. And that's where we started. But then we went into the oiled applications, pistons, etc. So turbos too, we got some more info on that later.
This is another great slide playing into application of devices that are manufactured that are actually pretty good, pretty close tolerance pieces. We just make them a little bit better, and it's an economic, as Andy pointed out. You look for a low-cost solution to bring that last little percentage or so of efficiency into the tolerances of any device. This is a great example. Works on the gear rotor pump pieces, housing, same thing with spur gear pumps. And also we've started to really grow the business into the area of dry sump. We've even done restoration for dry sump segments. And Jeff and I talked about this a little bit back in the old Can-Am days where we didn't have this capability. So we were kind of stuck, and we'd be rummaging around for the best of all the bad parts that we had collected. And some people think it's a no-no to go back and repair these, but this is a great economic. These things are expensive, and you put a little bit of debris or something through your engine, that's a shame to have to go back and buy a complete new unit. Send it to us. We can literally put that thing back into a nice, even, high efficiency pump for you.
No matter how precisely the manufacturers try to machine these, there's still going to be microscopic leak paths that you're not going to be able to see. So we were able to take those leak paths, and the feedback that we're getting from our customers with a coated pump is that with the same hot, thin oil at idle or low RPM, they're generally seeing at least a doubling of the oil pressure. This is a great slide that gives an example of that, and I think Andy can expand upon it.
Yeah, we covered this one last time in detail, but it's pretty neat. You can see some machining marks. This is a modern new pump. You can see areas where there's no room to make those impellers bigger or the ring because it's going to gall. But then you can see there's other areas where it's black and there's a lot of room for leaking. You got high and low pressure across this plateau, and same thing over here. And all this thick coating area here, that was a leak just going straight across the pressure differential. So
sometimes it's hard to visualize in effect what this means, but it does translate to improvement in efficiency, especially in these oil pumps, especially in some of our older engines where we get into performance automotive. People stay with the original engine architecture, and by design, those were pretty inefficient. They don't compare to today's manufacturing tolerances at all. Some of the aftermarket replacement pumps do, but just those little spots that the arrows are depicting here, that can translate to sometimes up to 10% losses with hot oil, as Mark indicated, at idle.
Yeah, so sorry, I'm jumping around so much. Yeah, these are just some examples. We can make bearings that are losing press, we can make them retained again, putting on the coating and jam them in there and they stay put. Do the backside of shell bearings if you had the line hone, or do whatever you had to do to make things right, and then you got loose parts. So a lot of neat applications, and we'd love to try to help you guys get where you need to go. Just call us up and we'll give it a whirl. So some more high-end race type superchargers, screw compressor components. We do a lot of those all over the NHRA track and a lot of tracks actually.
This slide illustrates that integrated skirt clearance that Andy touched on earlier, and graphically you can see here if your piston has motion as depicted here, lots of things are going in the wrong direction. You fill that gap with the coating and basically get the stabilization that can only be achieved by using a coating like line-to-lines coating, where it's going to self-fit as that piston heats up and gets loaded. The wear occurs, it breaks in, and you're left with the maximum amount of integrated skirt clearance on the full piston skirt. Now you're riding on an oil film at this point. A lot of questions that I got pushed back last time. Well, what about friction? You've increased the footprint, so you increase the friction. Not true. You're on an oil film, and behind that is what we like to refer to as just graphite and polymer or plastic.
Seems like we missed one, but
I'm gonna say tied into the integrated skirt clearance with the better ring seal. Another great byproduct of that is pan vacuum. I had one customer who had been running the same engine for years, said he was typically at about 5 or 6 inches. He was a street outlaw actually, and we coated the pistons for him. We had to put 12 thou on to get him back up to size, and he came back and reported he'd never seen the pan vacuum that high in that engine ever. It was up to about 11 inches, I think he said.
Yeah, a lot of guys have commented that, hey, I used to have pressure in my crankcase at the finish line, and now they're still in the vacuum side. So that's really an indication of blow-by. Period. So, we coat the piston to help the rings and the friction of the piston, but you help those rings settle down. Their life is just so much easier. Everything stays together longer. You don't beat your bores up as much. So, a lot of advantages, and it's not as costly to keep racing.
This is an excellent example. I hope you can see it, that we showed this last time. This is a TA2 Trans Am 2 engine, ran 4 full events, won 3 of them, was in the championship series winning driver's vehicle. These rings are still good according to the guys at Total Seal, and it's a great example of what the full integrated skirt clearance means. And this is coated all the way around the side of the piston through the pin boss, maximizing the stability of the piston and the bore. And that's what's achieved with the coating.
Yeah, so everybody asks about power. Will I get more power? On a new build, a lot of guys see a little bit more power, a percent or two. These engines have already been milked for power. So we're really happy when you get a percent or two on a new build, but 20 passes down the road or down the track, you're going to have a lot more power because your cylinder kit is not wearing out. The other neat thing is if each piston fits itself to each bore and all your rings are happier, the scatter among your cylinders gets to be way less. For example, Pro Mod 15 to 23% leak down on a new build. Now after 25 passes, they'll have 8 to 12% leak down. So they're getting a smaller range between their cylinders. I'm not an engine tuner, but that's got to make it easier to tune that engine and have confidence to go that little extra bit before you tear one up. So yes, you can make more power. We've got a bunch of dyno data, but this is just a neat one. Jason Farrell gave us the first indication that this stuff really works on a high-end motor. So we covered this one: development, race, production, restoration. This stuff can help people no matter what phase of this device's maturity is, we'll say.
I think we're primarily talking to a race audience here, but the restoration aspect is something that has really picked up. For instance, on the bearing slide, there were some cam caps that came out of an engine. I can't remember exactly which one, but they always tended to get very scored if the oil wasn't changed frequently. Debris would get in there and basically take them out of commission. And those are unobtainium. The guys say you can't find them anywhere. I even did a quick Google check and confirm that. But we were able to coat those up. He was able to put it back into the engine and it just worked fine. And that's just one example of many different components that people have come to us with that they can't find a replacement. It doesn't exist or it's too old, and we're able to help them out on that.
One of the other things that comes up, this coating's not just for professional race engine builders or race teams. If you look at most of the people that race in the United States, they're made up of sportsman categories, whether it's in SCCA or NHRA or what have you. And, the professional race engine builders are using these coatings for a couple of reasons. One is performance increase, and the other one is a higher endurance limit. They need to save money too. And so do all the sportsman racers. And, this coating is a great way for you guys to get an extended use out of that engine, as Mark just discussed, and save yourself some money.
The map that's come up now shows some of our different satellite coating locations. We're obviously at the headquarters there in the Metro Detroit area. And we really have the capability here to do either job shop, one-off R&D type coating, or scale it up to volume production, which we're also doing out of here. We do have facilities on both the East and West Coast for the convenience of faster turnaround and shorter shipping times. But we've got Brian over in South Carolina at Line to Line Southeast, and Chris is handling the West Coast at Line to Line Coatings West in Gardnerville, Nevada. And UEM, United Engine and Machine, makers of the Icon and KB piston lines, have also been licensed to apply our coatings. They've been doing it for a number of years, so you can order your coatings directly or your pistons directly from them with our coatings already applied. The exciting news is we're also in the process of bringing on a licensee in Australia. So I know they've got quite an active race market down there. We get lots of inquiries from both Australia and New Zealand, and guys who are willing to ship their parts, but probably would get a lot more if it wasn't for the distance and expense.
It's going to be great. We're all going there for the grand opening.
Can't wait. Another thing to mention is when you order pistons, through warehouses or manufacturers, you can always have them drop ship them to us, and it'll have your name on them. We'll contact you, coat them, and then forward them to you. So we do a lot of that, and that way you're saving some time and shipping cost. So here's this is a Ford Escort engine we built probably 60 times over the years, and these two lines on the top, that's our bore measurements over, let's see, like 45,000 miles. So you can see the bores were two different sizes. we coated the pistons. The blue one had more clearance. The red one was real tight with the coating. But as you run them real quickly, they both basically open up to the same proper gap that you actually need at your gauge point. And this gap is way smaller than the recommended bare piston to wall clearance. So quickie on that, and we covered the break-in really well last time, but we can do it again if you have questions this time. Yeah, this is a chainsaw piston, and we took the chain off while we were doing our study, so we didn't cut anybody's leg off, but we were just looking for noise and vibration changes, and the slide's kind of covered by our bubbles here, but this is like a 50% reduction in the vibration measured with a calibrated noise and vibe meter that was attached. And that's the same vibration that is ruining your rings and giving you tendonitis. And we're cutting that by 50%, just making that integrated skirt clearance much smaller. Again, that's the window that your piston has to rattle around. You get rid of that window safely and it all goes away, or a lot of it goes away.
You know, Andy, one of the things that we should mention here, we had the opportunity to work with Professor Harold Schock and his staff at Michigan State University. They've got a really terrific computer modeling capability, or they have modeling capability up there that's it's pretty interesting. And Professor Schock was in discussions with us about how eventually we're going to be able to measure how and what benefit this coating has to effectively dampen certain torsionals that are coming through the engine. These torsional vibrations are affecting the rings, as Andy just indicated. So hopefully by the time we speak again, maybe in a half a year or so, we'll have some information to help show what a benefit that is in, you know, a firing engine, in a race engine. Turbocharger.
Yeah, this particular slide is from a customer that had us coat his turbocharger compressor housing. He always took a lot of measurements when he was out at the track, and you can see there's 3 passes with an uncoated housing, and then he put the APC coated housing on, and his entire boost curve moved over to the left. So essentially at the same shaft speed RPM, he's getting more boost, and it continues to follow that line on up all the way up to I think he was running about 125,000 RPM on that when he reached the top end of it. This is a great example from one of our customers who was an owner operator of a freight hauling cab, and he had a used whole set turbocharger. We coated the compressor housing, and you can see that the coating is able to help it achieve a 0 clearance, 0 friction fit. It actually creates its own bed in the coating there, and this is after 150,000 miles of running freight back. I think it was a lot up in the hills of Wisconsin, and he kept it in service until all the components in the turbo went out. But he was very, very pleased with the results. Not only did he say that he picked up about a 7% increase in fuel economy, but that he was getting a lot snappier response with less turbo lag than he ever had before. This is just another photo of that same turbo. You can see on the right where the impeller wheel polished the coating in the area that it needed to find its fit. On the left is the impeller, and then that kind of illustrates after 150,000 miles, even having that tight of a fit doesn't cause any damage. It essentially just polished the tips of his impeller. But he was, again, extremely pleased with the result and the amount of service that he was able to get out of a used turbocharge.
So this is kind of our summary slide. If you can make your parts fit perfectly every time, it does a lot of great things. I'm not going to read them all because we can go to your questions, but we've observed these many, many times, and in prototype right up to high volume production, this stuff really happens. It's an easy way to get where you're trying to go. I will point out it's a lasting geometric, lifelong improvement to your components. That's kind of the key. We want this stuff to make your part a better shape.
And last.
Yeah. And I just wanted to point out that this presentation will be on our website, so you can review it again there. And we've got a lot of other presentation and papers also available. And if you go to our Facebook site, our customers love to share photos and videos of the builds that they've done or actual clips of the race that they've just won. And it's, we've been in the winner's circle countless times now, thanks to the skill of our racers and engine builders that are using our coatings.
Well done, gentlemen. We got through everything, and I think hopefully we have got some people out there right now that have got some questions. And Michael Cole, for example, he would like to know, are you doing much work with graphene? And also, Michael would like to know, does the FAA allow your coatings in their planes? So do you have FAA approval?
The answer to both of those is, I think, yes, on the graphene. And because graphene, it can happen when you just smear graphite. I guess it lines up the plates. We've had, I think graphene can form on the parts when they're running, because you're rubbing on the graphite, and that can set up that structure. But I've never done spectroscopy or any analysis to prove that, but it makes a lot of sense, and it picks up a shine that's really nice. On the FAA, yeah, we just got approved in Delta Hawk engines, which are coming online in production. I think they just got their FAA approval last year, and that's going to help people with small planes avoid the high cost of aviation fuel. They can use Jet A instead, much cheaper, and we're really excited about going into production with those guys. We're also in drones and stuff, military and civilian drones, but there's no people on those, so I guess they're allowed to crash a little more.
Well, those things, some of those drone engines that we're on require certification. So it's,
Oh yeah,
it's the same process.
Yeah.
Yep. And also some of the private engine builders where it's not under the FAA because it's a hobby type
Experimental.
airplane. I'm not sure how the rules go, but yeah, we've been in a bunch of passenger planes on a one-off type level. But that choice is entirely up to you. I'm not going to sign up for your safety.
I hear you there. Michael also would like to know, have you ever seen any difference in the CFM in a port coating? And then probably you're going to say yes on that also, I would assume.
In the CFM on a port coating?
Yeah, does it flow better? Because you put port coat.
We don't have any data. We don't have any data on that. So can't comment.
No, but we do get quite a few requests to coat the ports, both the exhaust and intake. We have various coatings for that. So the feedback has never been negative. Let me put it that way.
Well, I think that's probably an accurate way to put it, because I know, from experience, with some of the engine builders I've dealt with, that some of the coatings that we have run, we noticed an improvement in flow. And, I think the biggest thing is it smooths a lot of the turbulence in certain areas. And, it allows you to coat certain areas to make that air stay, stuck or better around the corner, I should say, according to them. So it seems like the versatility of your coatings would be, again, just pick whatever you want to try to improve on wear or any kind of performance level. It seems like it responds positively. I think that's the thing I take away from all this stuff that I've been writing notes for, whether it's making the longevity of the piston and performance of the piston inside of the cylinder more efficient, to pump coatings and, tightening the clearances up to where, you have less blow by and, more effectiveness without giving up friction. The friction is almost like a plus. I mean, you get the right amount of clearance put in, and everything works together. So reduces the drag or anything else inside there. So all the different applications, especially the restoration part of it, it's got to be almost like a major breakthrough when you're able to add material back in areas where it's next to impossible to do. I think that's the way I look at it. You're able to take your two components, and when you put them together, all of a sudden they work off one another and making it to where they improve the tolerances that has been, would have been lost forever if you hadn't.
Yeah, one of the things that can't be undersold from my perspective is the difference in bores, not only the size, but the configuration. A lot of the sportsman racers that we had, addressed earlier, those guys don't take their blocks down to somebody to do a hot hone, for example. Okay, so
Right.
you've got older configuration engines, still got a lot of conventional early small block Chevy engines out there, known to have bore distortion issues, etc. So they're going to do those. They're going to do like a torque plate hone, and that's probably going to be about it. And this coating is going to go contribute in a major way to straightening out the irregularities from a bore to bore to bore. Okay. And that's one of those little clicks of efficiency, very hard to measure, but it certainly is directionally correct.
Well, guys, Michael Cole, I think he must have a ton of questions here. He keeps asking questions like he said, thanks for the answers. Do you need a certain type of coating with high ethanol fuel?
Our coatings have run really well in all kinds of ethanol engines. I guess pro mods are methanol, but yeah, we've run in E85s, and yeah, that seems to be harder to find now. It seems like it might be going away a little bit, but for a while there was a lot of E85 activity, and people loved it.
Yeah, it seems like we pretty much run in about any fuel and or oil combination that I can think of offhand. In oils, it's been interesting. There's conventional, synthetics, castor bean, banana oil, some pretty exotic stuff, and the coating still seems to be happy in all of them.
If I had an alcohol engine, I'd demand this coating be applied to my piston skirts. That's known to be struggling a little bit when it comes to cylinder lubrication. If I can carry some oil on my piston skirts, I'm going to have a happier engine.
And I think anybody out there who's listening to this would have to concur, because there again, you try all the honing, all the boring and everything you do, there's no exact science. So there's always going to be a variance between 4 cylinders or 8 cylinders or 16 cylinders. So, you would think with your product, you're going to get almost a perfect fit. In the long run, it's going to make almost like a perfect fit for if you got the pistons and everything done correctly. You're really going to improve the performance, as well as I think the longevity of the part or piece that you're working on. So we still got some more questions here, guys. I want to make sure we try to get through those real quick. Have you ever used any coatings, your coatings on weapons, even in restoration of, old firearms, or even, the performance of new firearms? Has there been any use for that, as far as firearms are concerned? Or it says weapons, so I'm saying firearms, but weapons as a whole.
Yeah,
Yeah,
actually,
we've done a bunch of work on AR platform weapons, doing the bolt carrier group, and we can make it run really snug. It's a very highly porous coating, and you can oil your bolt carrier group, and then it looks dry. You drop it in the sand, blow it off, stick it in the gun, run 500 rounds, and pull it out. You'll see little spots where it's touching, where it gets wet with the lube, probably from the frictional heating. Capillary suction pulls more lube to those areas that are touching. And then you hold it and you watch the lube go away. So that's just makes them quieter, more precise. And we've restored some too, but we've been so busy in the automotive and other device areas, we haven't had time to push on that. But we also coated bullets to have less interference in the barrel, and have the coating make the seal, take your interference on the rifling areas. I forget the proper terminology, but we were trying to make it cooler for like machine guns, so you could get more longer bursts and not melt your barrel. And
that bolt carrier groups makes them more debris resistant. I mean, you did some experiments where we took a shot back and essentially reversed the flow on it, and we're shooting sand directly into the ejection port. And instead of having the bolt gobbling up sand as it's slopping around and cycling back and forth, it would shear the sand off because it was a much tighter fit. So uncoated, you get 7 rounds. Coated, I believe it was 28 rounds under those same conditions.
Yeah. Big difference right there. Peter would like to make a comment. An industrial engine company in Springfield, Ohio, coated cams during run-in, but did not recoat. Is your coating durable?
We don't really have data on that. People ask about flat tappet engines. They'd like to. We just had a gentleman maybe a month ago. I thought we were going to try it. We do have some really strong, durable coatings that, if you're abradable and you've got line contact, it's going to keep abrading under a high load. If an area doesn't form to kind of spread that load out, it may keep going. But adjacent, like on a gear tooth, that the active area of a gear tooth, there's a little window in a part of it that really takes the load.
Yep.
We can coat that. It may wear through that high load area, but it creates a longer leak path for the oil to get out of there. So, you tell us if we can help you, we'd be happy to coat, but we don't have good data on, that type of application.
Andy, it might be a good time to point out the difference in coatings. The piston skirt coating that we apply to a 2-cycle or maybe an aircraft engine is not going to be the same as others where we move up the hardness food chain.
Right. And the bearing coatings, they're obviously designed to be real thin. And if you do pierce the oil film, then we don't want it to wear. We want it to stay put. So, most of our coatings have been, instead of having your oil film fail and then a coating to save the day for a couple seconds, we want the oil film not to fail. That's what our coating does. But in cases like the bearings, there's just too much load and they will touch, and it's worked great there. So we'd love to work with you. We'll just coat the parts and hope you give us feedback.
Yeah, and thanks to
I want to get one last one in here real quick, because David asked the question or made a comment of, I imagine these coatings could improve accuracy and repeatability of the machines that produce engine parts, lathes, boring bars, and milling machines, which I think you're pretty much, you've touched on that, but I want to make sure that question got put back out there. And last but not least, Michael's got one last thing in here. He said he didn't think about coating barrels when he referred to the weapons, but he also said, do you do DLC coatings?
No, we don't do DLC. There's people that are really good at it. And they're another thin coating that prevents big damage when your films fail. And on the gun barrel, we were coating the ammunition, not the barrel.
Okay. Francis?
Well, but thank you very much. What a great session. I'm glad. I mean, you deserve 2 sessions. We couldn't cover everything in one. So it worked beautifully, and we're delighted to have you back with us this week. We'll post also the presentation on the ePortrait platform. Will be available later today. We also pushed line-to-line products back on the homepage of the ePortrait platform. So please, for more information and updates, visit www.eportrait.com. You'll find everything there. We have been recorded this webinar. It will be posted later again on the platform, distributed our newsletter and social media channels. Next webinar will be on modern machining method for cylinder heads by MEC CNC. Again, thank you very much, gentlemen, and we'll see you again soon.
Thank you.
Thank you. See ya.
ePortrait is a digital platform that we've created basically to make life easier in the business community of auto racing.
ePortrait, there is no e-commerce. It's literally a connection just like at a trade show. So now, any time of the year, a buyer could reach out to a supplier.
When you see a product that you're interested in, all you need to do is click on request more information, and then from there it is forwarded directly to the buyer or to the supplier.
ePortrait really eliminates having to travel, closing down your shop. Now you have a place to showcase globally your racing product and technology.
Land speed record holder George Poteet's Speed Demon rocketed 481 miles per hour at the Bonneville Salt Flats. You don't go that fast without ARP fasteners.
There is no way that we could go the speed that we've gone, the number of times we've gone, with a lesser quality bolt than ARP supplies to us. And we absolutely wouldn't be where we were today if it weren't for ARP.
When failure is not an option, it's ARP-bolts.com.
We're Performance Plus Global Logistics. Our team of dedicated performance industry and logistics experts get valuable cars and components to the track on time in top condition. We provide expedited logistics solutions for the performance industry using direct routes instead of deferred options, and communicate all necessary information to the appropriate resources to meet regulations and ensure a smooth transit and secure delivery, both domestically and internationally. And we exceed customer expectations by providing best-in-class service with an efficient and cost-effective system in place. Contact us today to book your next shipment.
You work as hard as your truck, and you have no time for downtime. That's why more truck owners trust Blue Def, America's #1 diesel exhaust fluid brand. Each batch is guaranteed pure, so you can avoid costly repairs caused by inferior DEF. Demand America's best for your truck. Blue Def and Blue Def Platinum. Put trust in your truck.
With roots in the Midwest that date back well before the Model T, Fifth Third Bank has a long history of serving the needs of automotive companies. While much has changed over the years, our passion for helping businesses put cars on the road and on the track has not. Today, we are more committed than ever as a member of SEMA, a founding member of PRI, and a sponsor of multiple race teams across several racing series.
For over a decade, Fifth Third Bank has been a staunch supporter of our industry and a great partner for many companies in the motorsports field.
Our business has been growing extremely fast, and really we could not be where we are today without Fifth Third. They provided amazing strategic advice, the capital we need to support our phases of growth.
They are true partners for me now, and what they do with their involvement in motorsports is untouched in this community.
Where can we take your business? Fifth Third Bank.
Where will you find Ferrea racing components? Circle track, drag racing, and any top race shop. In every form of motorsports competition, our valves and valve train components deliver race-proven design and technology. And we've brought that same performance to our street applications as well. We're backed by 5 decades of experience, an extensive range of off-the-shelf components, and our custom valve department has the fastest turnaround times in the industry. Ferrea Racing Components. Stand with us or race against us.